Hi, I'm Salvador Ramirez, a program manager working on the .NET Microframework team. In this video, I'm going to introduce you to the .NET Microframework and show you how you can use it to write applications for resource-constrained devices using Visual Studio, C#, and .NET. During this video, I will first introduce you to the framework and answer questions such as, what is the .NET Microframework? What is it used for? What types of devices can it run on? And how you can get started writing applications. Second, I will demonstrate the developer experience when writing applications on a microframework-based device. And finally, I will discuss how you can get involved in the community. The .NET Microframework is an open-source platform that enables you to write, manage C# applications using Visual Studio for resource-constrained embedded devices. The Microframework is open-sourced by Microsoft Open Technologies and licensed under the Apache 2.0 license. Microframework can be used to write applications on resource-constrained devices running on a microcontroller with just a few hundred kilobytes of RAM and storage. The typical Microframework device has a 32-bit processor with or without a memory management unit and could have as little as 64K of RAM. Some examples of devices that can run the .NET Microframework include home automation controllers, sprinkler system controllers, and smart thermostats. In more industrial scenarios, microframework-based devices have been used to monitor and provide remote configuration capabilities to industrial electric and heat generators. We also enable a rich developer experience thanks to the integration with Visual Studio. As a developer, you can take advantage of the same development and debugging tools of Visual Studio to easily write applications for microcontroller-based devices. The Microframework provides .NET-based libraries for common serial buses such as SPI, I2C, and traditional UART to interface with sensors, motors, and actuators. Application developers can interface with those peripherals without having to know the intricacies of the microcontroller running on their embedded device. In addition, developers can use Visual Studio, C#, and their .NET knowledge to quickly write embedded applications. A developer can purchase a Microframework compatible board, connect their board to their development computer running Visual Studio, and start writing applications for physical devices. No extensive knowledge of hardware design is needed to get started writing code for physical devices. To get started writing applications on the Microframework, you need to first buy the hardware that will be running your application from one of our partners. Second, you need to set up your development environment. This involves installing Visual Studio, our Microframework SDK, and any drivers and libraries specific to your hardware. Finally, you need to connect your hardware using a USB cable to your development machine. You can then use Visual Studio to create a new project and write your application. While the existing Microframework hardware available from our partners is great for general purpose projects, for commercial or more advanced solutions, you may need to design and implement your own custom hardware board to meet your specialized or commercial requirements. In those cases, you will want to design your hardware and then port the Microframework to your custom hardware. Now, let's jump into our demo. As you can see on my right, we'll be coding against the NetDuino board, so let's get started. I will now demonstrate how to create a Microframework project with Visual Studio and show some of the debug and API capabilities of the framework. So first I open Visual Studio, I select New Project, and I select the NetDuino 2 Plus application template. The reason for this is I have a NetDuino Plus board connected to my laptop through a USB cable. So I create the project, and then for this sample application, I'm going to control an LED, an onboard LED, through some sample code here. So first I define or select the pin that controls the onboard LED. And I am initializing it to be off. And I will now write some code to toggle the LED between the on and off states. So as you can see, the IntelliSense functionality of Visual Studio makes it easier for me to write the code. And so I've created that line to turn the LED on, and now I will add a delay so that we can actually see the transition of the LED. And also to demonstrate some of the debug capabilities and integration with Visual Studio, I will write a statement to the output window. And so the debug print statement, and I now toggle the LED to the off state with this second set of statements. And that's it. With that code, I can turn an LED on and off without having to know all the intricacies of the microcontroller that's running on the .NET Microframework board. Now that the code has been compiled and flashed to the Arduino board, we can see in the output window the statements indicating that the LED is on and off. Now, this was a very simple example of what you can do with Visual Studio and the Microframework. In more complex applications, you might be interfacing with motors, actuators, sensors. In the same way that you saw the IntelliSense functionality to turn the LED on and off, you would have the same capabilities to interface with those additional peripherals. The .NET Microframework is an open source project. Be part of something exciting and shape the future of micro devices by contributing to our project. Whether you want to showcase your project, share libraries, or enhance the core of the Microframework, you can learn all about it by visiting our website, netmf.com. Thank you so much for watching this video.